Hello everyone and welcome back. This video is going to be about classes, specifically classes in Python and why we care about them. Objectives for this video are listed here. By the time it's over with, we want to be able to kind of define what classes are and define what attributes and methods, what those words mean in relation to classes. We want to be able to create classes using syntax in Python. We want to set up an init method. Oftentimes you'll hear this referred to as dunder init because that's 2 underscores, so double under. We're going to add custom class methods, we're going to set default attributes, and we're going to differentiate between class variables and instance attributes. Those are very closely related, but they're 2 different things. And finally, we're going to use class inheritance so that one class can inherit from another class. So what are classes? Basically, classes are templates, or you might think of them like blueprints for making objects. The classic example is you have a blueprint for a car or for a house, and that's not the actual house. If you've got a blueprint for a house, that's great, but you have to actually build the thing. The blueprint just tells you how to build it. It tells you all the specifications. It tells you how many bedrooms it's going to have, how many bathrooms it's going to have, how big it is, how many floors, so on and so forth. But if all you have is a blueprint, you can't sleep in that. You can't move into a blueprint. You have to actually create the thing. So a class is a blueprint, and then you create what's called instances of that, and those are the actual things. You can use that class to create a whole bunch of different instances, just like you can use one blueprint to create a whole bunch of different houses. So why do we care? Number one, we can use them over and over again. This means that we can code things once and then use that same code over and over again without having to write it over and over again, without having to debug it over and over again, without having to update it over and over again. You just do it in one place, and then the interpreter will automatically kind of propagate that out for you into all your different instances that use that. It's also important because Pygame relies on classes very heavily. Pretty much everything in Pygame that we're going to use is a class. So the better we understand classes, the better we're going to be able to utilize Pygame, and the quicker you'll pick up on it and less of a learning curve you're going to have. So let's give kind of a high-level theoretical example using Super Mario Brothers.
It's me, Mario!
If I was going to code up Super Mario Brothers, I would have to think about all the different things I would need to code, all the different objects. We're going to focus on Mario first. So how would you code Mario? Well, there's 2 main options. There's the first option is you can just hard code it. You can hard code in exactly what Mario is going to do. You're going to hard code in his data, the little image for the character. You're going to hard code in his sound effects. You'll hard code in how high he can jump. You'll hard code in the code to make him jump and to make him move, to duck, to grow when he gets a mushroom, to shoot fireballs, all that stuff. You write the code. You'll notice option 1 and option 2 are pretty much the same at this point, because you're going to have to write that code at one point. So you can either hard code it into the Mario object, or you can hard code it into a class and then use that class to build the Mario object. As of right now, we're not really doing ourselves any favors because all we're doing is writing the code. When it matters is when you have to do something else like create Luigi. If we did that first option, if we hard-coded it into the Mario object, we would have to repeat all of that information for Luigi. We would have to write all of his data, all of the properties, and recode every single action. How does he jump? How does he move left? How does he move right? How does he shoot fireballs? We would have to put that code here. We would have to copy it over and paste it into Luigi. And then anytime we make any changes, we have to find all that code and update it in all the different places. And this gets more and more difficult to maintain the more times we use it. So in Mario Brothers, you've only really got Mario and Luigi who have all those things, but you've also got Bowser, you've got little Koopas, you've got the Goombas, you've got all these different enemies, all this different stuff. All of them don't need the same actions, but they need some of them. For example, everybody needs to know how to move, everybody needs to be able to jump, everybody needs to be able to die, everybody needs to be able to do all those different things. So instead of writing it over and over and over again, we can use a class. We set up one class, maybe call it character, and then we just code it one time, and then use that for every single character we're going to do. Alright, so now I have PyCharm pulled up, and we're going to start learning the syntax for creating classes. It's actually very simple at kind of the bones of it. So to create a new class, you simply write the word class and give it a name. So let's say we wanted a character name. Class character, and that's it. That's all you need to create a new class. You'll notice here I capitalize the C in character. That's convention. You want to capitalize or use title case for any classes. That's just kind of the convention for it. And I wrote pass here so that the interpreter doesn't yell at me, because if I get rid of pass, the IDE is going to underline stuff, because you have to have something in there. So I just wrote pass for now. This, by the way, is where we're going to put all our attributes and our methods. Attributes are variables that are attached to instances of a class, and methods are functions that are attached to instances of a class. So just think about attributes as variables and methods as functions. They're just different terms. It's just whenever they're attached to a class. So let's go ahead and create a new character class. To do that is very simple as well. You just run your variable name. So let's do Mario equals character, called as a function. And that's it. All right now, if we print Mario to the screen, let's run main. Then we have a character object. Don't worry about this dunder main, but we have a character object, and it tells you the memory reference. So right now we have a new character. If we create Luigi equals character, print Mario and print Luigi, and run this, now we have two characters. They're the same, except they have different places in memory for obvious reasons. So that's all there is to creating a new instance of that character. What's cool is anything we put in here, anything we put in this class definition will be applied to both of these. It will be applied as many times as we run this. As many times as we run this character, we can do this for Bowser. We can do it for Peach. It doesn't matter. As many times as we run this, all of the code that's in here will be duplicated so that we only have to maintain it in one place. We only have to write it in one place. It's pretty cool. But as of right now, these are just empty classes. This doesn't actually add anything, doesn't do anything for us. The first step to adding some real functionality, to adding some meat to this, is using what's called the dunder init, or the init method. This allows us to pass in data to our characters when we're creating them. So in order to create that, you have to define a new function. So def underscore underscore init, and this name is important. And you'll notice that PyCharm already put in self for me. We haven't gotten there yet, but we'll talk about that in just a second. And then you have to put something inside this init function, just so the interpreter or the IDE quits yelling at me. I put pass. There's a few things to this I want to break down. The dunder init, that's what this is called because it's double underscore. That name is very important. If you use anything else, it will not work. This is a reserved name, and you have to use that. You can't call it initialize or whatever. Oops. You can't call it initialize or whatever. It will not work. You'll notice that PyCharm is telling me because it changed the color of that. When it's init, it's in pink right there. So what this allows us to do is it allows us to pass in variables whenever we're calling it. So let's say for Mario, for example, let's say we wanted to give him a name, give him a speed, say how high he can jump, and give him kind of a catchphrase, because each of these are going to be different. So what we would do is we would pass that in as arguments. So self, name, speed, jump, height, and catchphrase. And then inside of the init function, we just set those variables. Self, which is the first one, you don't have to call it self. You could call it anything you want, but the convention is self, and I highly, highly, highly recommend that you leave it like that. So self.name equals name. And this is going to seem a little repetitive. Self.speed equals speed. Self.jump height equals jump height. Self.catchphrase equals catchphrase. What this is doing is when the class is first created, what this does is that when the class is run, whenever I'm creating Mario, whenever I'm creating Luigi, we pass in the information right here. By default, Python will set the first argument to self on this init, so we don't have to pass self in, but we have to pass in all the rest of these. And what this is going to do is this self is kind of like the this keyword in JavaScript. It refers to whatever object you're creating. So a self right here, when it's run here, will refer to Mario. When it's run here, it will refer to Luigi, so on and so forth. So what we're doing is we're setting Mario's name to whatever we pass in, Mario. And the second one is speed. So let's say he runs 10 units, 10 speed. We haven't really defined what that is yet, but let's say he jumps 12 high, and his catchphrase might be, "Let's go." And then for Luigi, it would be different. Luigi, I think he runs and jumps the same height as Mario, but I'm the best is his catchphrase. Then for Bowser, he jumps a little bit higher than both of them, but he is slower. Then he says, "Wah, ha, ha." And then Peach would be Princess Peach. Her speed, she does not move in the original Mario games. She does not jump either. And she says, I don't know, "Save me, Mario." It's been a long time since I've played the original Super Mario Brothers. So now we have these four classes, these four instances of this single class being created. And what's going to happen when I run this, let's just go ahead and do it so you can see it. This doesn't look like it changed. However, I can print Mario.name and Luigi.name, and it saves that information. Now, because we've set this up this way, all of this information that we passed in is attached to this object. Mario, all of this information is attached to this object. That's why we had to do the self thing, because that way it allows us to reuse this, because we're attaching these to the thing, to the self, whenever it's run. One of the biggest mistakes I see, or the most common mistakes I see, is people forget to add this self here. That's why PyCharm is real nice, because it automatically does it for us. But just make sure that you add self as the first argument to the init method. And this is super useful, because it allows us to pass in data when we create the class. If we didn't have this, we would have to do all of that manually. So let's say for Mario, we wanted to add a score, and we didn't do it here. We would have to come down here and do Mario.score equals 5,000. And then down here, we could print Mario.score and run, and this works fine. It's just not nearly as nice, because then we have to come to each single character, Luigi.score equals 4,000, and you can see how this is a lot of repetition that we don't need. If we simply add it in the init, then we can just put it into the method, into the function call whenever we're creating the character. The next thing I want to talk about is how you can add class methods. Just like these right here are class attributes, you can also add class methods, which are functions, because a method is just a function attached to an object. So you can add methods. Examples of methods that we might use in this game might be move left, move right, jump, shoot fireball, so on and so forth. So let's focus on giving our characters the ability to move left and right. So after the init definition, right here, instead of doing pass now, I'm going to go ahead and define a method. So define move_left. Notice that self is still the first argument passed in. Self will always be the first argument passed into class methods, whether it be the init method or any of the other custom methods. And then inside of this custom method is where we would put our code that actually moves Mario or Luigi or whoever to the left. So code to move left here, something like this. It'll end up looking something kind of like this. Self.position.x minus equal to self.speed. So basically what this is doing is taking the self means this thing, whatever the thing is, doesn't matter what the thing is, because I can't just put Mario here because I want this to be used in all of our characters. So self.position.x, this is the x coordinate for the position, just move it to the left however much its speed is. So you'll see here that the characters that are faster, like 12 here, 10 here. So see that characters that are faster, like Bowser here, who moves a little bit faster apparently, in our example, is going to move to the left 12 units, while Mario and Luigi will only move 10, and that's per tick. So you can see how the speed is factored in there. And you could do the exact same thing with move right, except it'd be def move_right. And then I'm just going to copy this, except instead of the minus, it's going to be plus. So something like that. This is not the actual code, the exact code or anything like that. Once we get into Pygame, we'll learn the actual code for doing this. This is just kind of pseudocode so you get the understanding of how this works. And the way that what this is going to do is whenever we want this character to move to the left, all we have to do is call Mario.moveLeft. Like that. Now this will throw an error if I try and run this because there is no self.position. But you see how this works, and this works on Mario, this works on Luigi, this works on Peach, on Bowser, on all of them. Then we'll be able to call these same functions, and we only had to write them one time. That's why one of the many reasons classes are awesome. Another example is we might have them say their catchphrase. So def, we'll just do speak. And what we're going to do here is all we're going to do is print self.catchphrase. And this one will work without throwing any errors. So if we call Mario.speak and then Bowser.speak, let's run this. Let's see, no attribute score, because I'm still trying to print score. So let's just get rid of these, save, and run it. Mario said, let's go, and then Bowser said, wahaha, just like he does in the game. So you can see how this one method is applied to all of these different characters, and it will work on all of these different characters using data that we pass in. So we can, that's what's one of the cool things, is that we can pass in this data and use that data inside of these methods. And again, one very common mistake I see with these is that people forget to put self. So make sure that you pass self as the first argument every single time in every class method. If you don't, let's say we forgot to do this, then let's try run. Uh-oh, type error. Speak takes 0 positional arguments, but 1 was given. So it's just because what's happening is this is saying speak doesn't have any arguments, any inputs, but whenever you call a class method, it automatically sends self as the first one. So you're calling it with self, but it doesn't take any. So it throws that error, which is why ELF, which is why you need that self in there. Let's go ahead and run that again. Perfect, works like a charm. The next thing I want to talk about is how you can set default attributes. This is oftentimes useful if you have like a default speed, for example, or a default jump height. You might not want to have to set that on each time. So let's say that all of our characters have a jump height of 10. Let's say that every character jumps 10 except for Peach, because Peach doesn't jump at all, she doesn't move. Well, it's kind of annoying to have to write 10, 10, 10 each time we're creating this new character. Instead, we can just use Python's default argument parameters to do that automatically. So in order to make this work, up here at the top, instead of putting speed here, let's cut it out and put it at the end. And you just put equals whatever you want your default value to be. So what this is going to do is if, when you're creating it, you pass a value, it will set speed to that value. If you don't pass a value, it will set speed equal to 10, which means that down here, we need to move this, rearrange those. Oops. This one is not going to have one, not going to have one, not going to have one, and this one is going to have 0. So let's just print those so we can make sure it works. Print, Mario.speed, and then print Peach.speed. And run it. There we go. Mario is 10, even though we didn't put a 10 anywhere in here. And Peach is 0 because we overrode it by adding that value manually. So the reason you have to put the speed or your default variables, default arguments at the end is because you can't have an empty argument in Python. So you have to put it at the end in order for it to work. And if you have multiple ones of these, it gets a little bit hairier, but you can still do it. So by using that default, speed equals 10 or equals whatever we want it to be. It can be 10, it can be 100, it could be fast, whatever we want it to be. It will just set that value for us if we don't pass one down here. So we only pass one on Peach, so the rest of these have a speed of 10. Next thing I want to talk about is class variables versus instance attributes. Now this is kind of getting into the weeds a little bit, but it's an important thing to understand. Class variables are going to be shared by all instances of a class. Instance attributes can be unique among different instances of that class. So for example, the name, Mario, Luigi, Bowser, Princess Peach, these are instance attributes because they can be unique among all of the instances here. Another example is the jump heights. Mario and Luigi are the same, but Bowser and Peach are different. Those are unique because they are applied to the actual instanced thing, to the object that you're creating, that results from the class, not the class itself. However, sometimes you want to make sure that all instances of a class have the same variable. An example of this might be the strength of gravity, because we're going to want all of our characters to fall at the same speed. Class variables are defined inside the class, but outside of the init method. So these init method, all of these are going to be attributes. They're going to be instance attributes. Anything declared outside of that, any properties declared outside of that, any variables declared outside of that are going to be your class variables. By convention, you put them at the top above the init. They don't have to be, but that's where most people put them. So I'm actually going to put it above this comment because that comment are your attributes in your methods, while up here are going to be the class variables. So let's say gravity strength equals 3. And now what's going to happen is that all of these are going to have a gravity strength equal to 3, just like you would expect here. But what this does is that we can guarantee that all instances of character will have the same gravity strength. So if I come down here and print gravity strength and gravity strength, they're going to be the same. They're going to be 3, even though we didn't set them here. And you can't set them here. There's no way for you to mess this up to accidentally set gravity strength to something else inside your constructor, because it's not in the init. You cannot mess that up on accident. The only way that you can do it is if you manually set it down here. And the only way that you can change this is to set it manually. So if I did Mario.gravity strength equals 5, now what's happened is that I have created an instance attribute on Mario that overrides the class variable. So if I save this and then I again print Mario.gravity strength, and then when I run that, you see that it's 5 because I have created a instance attribute of gravity strength by adding it on here, but I have not changed the class variable. That class variable is still 3. But because I created the instance attribute manually, I overrode that class variable for Mario. That's a little bit, again, in the weeds, a little bit esoteric, if you will, but it does matter. That being said, this is not a good idea. You don't want to override your class variables. You want your class variables to apply to all of your characters. You only want to use things here that apply to all the characters. The only time that you might not want to do this is if you have one class inheriting from another class, then you can override it. So let's say that you had a character with a gravity strength of 3, you might have a character that flies or floats or something like that. They might have a different gravity strength, but you would override that in the child class, not in the not on the individual elements. And that segues nicely into class inheritance. So what is class inheritance? Oftentimes we will want subclasses, or children classes, another term for them, to inherit attributes and methods from a parent class. This is useful for creating more specialized subclasses that add additional functionality that we might need without altering the parent class. To give you an example, right now we have a class of character that we're currently using for Mario and Luigi and Bowser and Peach. Well, Mario and Luigi have functionality that Bowser doesn't need, or that Peach doesn't need. Bowser has some functionality that Mario and Luigi don't need, and Peach doesn't need. But Peach doesn't really have any functionality. She just kind of stands there, so we don't really need a subclass for Peach, I wouldn't think. But we might want subclasses for both Mario and Luigi, and then for Bowser. Now, Mario and Luigi, we might create a subclass called Player. So you would just create another class Player, right here. But the difference is, and I'll go ahead and just add pass so that it doesn't yell at me. The difference is, since this is a subclass, we have to put it like a function and pass the parent class in there. And what this tells Python is, hey, I'm making a new class called Player, but I want it to inherit everything from character. Right now, Player and character are the exact same. If I change this to Player and change this to Player, none of our functionality will change. It all works the exact same because all we're doing with player is creating a copy of character and then doing nothing with it. So right now this works fine. There's nothing wrong with it. It's just kind of pointless to create that second character. So now that we've done that, let's go ahead and add some functionality to Mario and Luigi, because they're both players while Bowser and Peach are characters. So let's add, I don't know, a method to shoot a fireball. So let's def shoot fireball. And remember, we have to pass self as the first argument. And I don't know how in Pygame off the top of my head to shoot a fireball, and I don't have Pygame installed on this interpreter. So code to shoot a fireball here, and for now I'm just going to print to the screen. Print. Boom! Headshot. So now we've got this. And if I come down here, I can do Mario.shoot fireball, and let's see if it works. Boom, headshot. However, if I do Bowser.shoot fireball, it's going to throw an error because it doesn't exist. Character object has no attribute shoot fireball. So you can see that the player, the child, inherits everything from the parent, but it is a one-way relationship. The parent does not inherit anything from the child, just like in real life. The children get your genes from your parents don't get any genes from your children, they got it from their parents, so on and so forth. And another cool thing you can do with these subclasses or children classes is you can add to or change the init method. So let's do def dunder init, and we can add additional attributes to that. So we've still got to get all the same ones that the parent got. Name, what'd we do? Jump height, catchphrase, speed, and we set it equal to 10. And then what if we need health? By default, health might be 1 because you got like little Mario, and then if you get big Mario, we might set his health to 2. And then maybe a score. And by default, it'll be 0. So now we have this longer, more kind of in-depth init function right here. So the first thing we need to do, and this is important, and this is the number one thing I see with subclasses or children class that people forget, is you have to call the super, is what it's called. Super, like that, is basically, this means get the parent class. So we're getting the parent class, and then we have to run the parent's init, passing in the same information: name, jump height, catchphrase, speed. So this initializes the parent's part, and then we're going to add on to that our special functionality. Self.health equals health, self.score equals score. So just to look at this again and kind of go over it one more time, because this is where some people start to get a little bit confused. Whenever you have children, you have to call the parent's init if you're going to add things to it. If I wasn't going to add any of this, if I wasn't going to update the init, I don't have to do it. But if I'm going to add things to the init, you have to take in all of the same arguments that you already took as the parent, that the parent takes, and for your the first line in that init function, you want to call the parent's init function. You do that with super, call it as a function, super, open and close parentheses, and again, all this does is get the parent. It gets the parent class. So you got parent class dot init, and you're calling that init function, which is the exact same as it is up here, except for the self. And then you're passing in those variables that the parent calls for. And then after that's done, you can set your additional ones, like that. And I just want to highlight and reiterate, when you're calling the parent's init, you do not pass self. You do not pass self in here. It'll throw an error if you do. So, I mean, you'll learn pretty quickly that you can't do that. So let me run this. Oh, what's going on? Super init, so on and so forth. It takes from 4 to 5 position arguments, but 6 were given. So in other words, you gave me too much stuff. So let me get rid of that. And it works again. Character object has no attribute, shoot fireball. Where are we going? What did I do wrong? Oh, that's that one that I left in as a purposeful error. You go away. There we go. Works fine. And I can also now print Mario score, and his score is 0. And we can test all of this. Let's create a new character. Wario equals player. Name is Wario. He has a jump height of 8 because he's kind of fat. I'm gonna win. We'll give him an 8 speed. But he is a player, so now we can do Wario.shoot fireball, and we can do Wario.speak. I'm gonna win. So boom, headshot, and I'm gonna win comes from Wario. So you can see how now we only wrote this code one time. One time we wrote move left, move right, speak. One time we wrote shoot fireball. But we can apply it to as many different objects as we want. This is super useful throughout all of programming, but especially in game development. Because just think about all your favorite games, and think about the fact that now that we know how to do classes, we can apply that in so many different ways. So to summarize, let's look back over our objectives. We defined what classes are. We talked about how there are templates or blueprints for creating objects. Talked about attributes and how those are basically variables attached to a class or to an instance of a class. We talked about methods and how those are functions attached to an object or to instances of a class. We learned the syntax for creating classes in Python. It's very simple, just the class keyword followed by whatever you want your class name to be. We talked about the dunder init method and how that's very important for being able to initialize. That's what init stands for, if I didn't mention that earlier. To initialize your classes with starting information, with starting attributes. We added customized class methods such as shoot fireball or speak. We set default attributes by using the equals. So for example, speed equals 10. You could do that for any of those arguments. We differentiated between class variables and instance variables, where class variables are attached to the class itself, and they are the same throughout all created instances, and how you should not override those unless you have a very good reason to do so. And then we talked about how those are different from instance attributes, which are or can be unique between each instance. We also talked about how you can use class inheritance so that you have a parent class that gives a lot of its attributes or its methods or whatever to a child class. And that child class can take everything from the parent, it can overwrite some of that, and it can even add its own additional functionality. For example, the example we used was player, and how the player needs to be able to shoot fireballs while the character does not, because Peach and Bowser don't need to shoot fireballs. Or if they do, for example, Bowser, he does shoot fireballs, but they behave in a different way than the player ones do. So he would need his own shoot fireball method that's different from the player shoot fireball method. Now this video was quite a bit longer than the ones I normally try to make, just because there's so much here, so don't feel bad if you had to kind of pause it and come back later. That's perfectly fine. As always, if you have any questions, please let me know. I will be happy to help. Thanks.